Alright, chapter 7, the first half is all about exponents. And I really enjoy it. Hopefully you agree as we get moving through the chapter. But we're going to start today kind of looking at some stuff with exponents. The first things will be stuff that looks familiar, pretty sure, and then we'll move on to some stuff that probably doesn't. But starting out with positive exponents, I'm just going to write a few out. Like if we have a 5 to the third, that when you see a 5 to the third, if you know that that means 5 times 5 times 5, that's kind of what you're picturing in your brain, you're off to a good start. So 5 to the third is 125. The common mistake is people just write down 15. You have to get in your head that exponents are different than just doing the 5 times the 3. But it's 5 times itself 3 times. So moving on, so if we have a 7 squared, that would just be a 7 times itself twice like that, which gives us 49. So looking at those, to punch them into your calculator, you probably have a calculator that'll either do a 5 and then a little caret and then a 3. You could hit equals for that one. Or perhaps the button here is like a little x to the y key, depending on your type of calculator, or maybe a y to the x. The one down below, you could do that same thing. You could do a 7 and then whatever one of those buttons and then a 2 equals. But I'd get in the habit, you should have, all calculators should have a little x squared button. And if you just do 7 and then that, and then it equals, it'll give you the 49. Okay, but so what they're saying there is this. The exponents for now are always going to be a natural number, or at least a number that doesn't have a decimal. And so we'll write a b to the n, a b, because that stands for the base. And what that's saying is it's saying b times b times b times dot dot dot. Eventually we'll end with a b, or times b, but we have to have n of those b's there, so n times. So that in red is kind of like the definition of an exponent, something kind of along those lines. All right, moving ahead, we want to look at like what happens when you have 0 as an exponent. That I think is going to be perhaps the first new thing. Well, if you have your calculator, you could type some of these in. If you type in 5 to the 0, it gives you a 1. If you type in a 7 to the 0, that'll give you a 1. So I'm going to go and kind of write our little rule here in red that b to the 0 equals 1. But that's not always true. That's only true as long as b, the base, does not equal 0. So you could say any number to the 0 power is 1, except for 0 to the 0. That's undefined. And you don't need to know why, it's just kind of cool. But here's why. You're going to learn kind of the rationale behind it later. But let's say you have 5 squared over 5 squared. Well, that's the same as saying, and you don't need to write this, this is just, I think, cool. The same as saying 5 times 5 over 5 times 5. Well, we can reduce when we're multiplying like that. Oh, this 5 could cancel with this 5. And this 5 could cancel with one of the 5s down below. So you end up really just with 1 over 1, which is 1. So 5 squared over 5 squared is going to equal 1. But the other thing you could do with that, and this is the part that we're going to learn later, is that when you have the same base, so 5 to a power and 5 to a power, and it's divided, you could write that then as 5 to the power in the top minus the power in the bottom, which then tells us that's the same as 5 to the 0 power. So 5 to the 0 power has to equal the 1. So that's essentially what we just wrote at the top, that 5 to the 0 is 1, or a number other than 0 to the 0 is 1. The reason it can't be 0 goes back to, can you do a 0 over 0? That right there is illegal. You can't divide by 0, so that's why the base, b, can't be 0. All right, that's just me getting excited. For now, pretty much anything other than 0 to the 0 is 1. All right, negative exponents. We could take and figure out some of these things with our calculator, perhaps. So if I do 2 to the negative 3, I'm going to leave a little space because I want to write something in there later. But if you do that in your calculator, that's going to be 0.125, which I'm going to kind of work to the left then. 0.125 is 1 over 8. If you do 6 to the negative 2, yeah, I didn't plan that far ahead. I don't know the decimal for that. But that's going to be the same as 1 over 36. So you might not have noticed it with the 8, but I think the 36 will look familiar. That 36 is really just 6 squared. So 1 to the negative 2 is the same as 1 over 6 squared. And 2 to the negative 3, well, that's going to be the same as 1 over 8, which is the same as 1 over 2 to the third. So when we have a negative in the exponent, what that's saying is it means do the reciprocal you can remember reciprocals are where we flip the fraction of the base. And we just take whatever that base is and we just flip that. That should come up a little bit later when we do some of these practice questions. But essentially, we're looking at this as being, well, that's the same as 2 to the negative 3 over 1. And when we have this negative exponent, we're taking that and we're putting it in the other part of the fraction. All right, to round out the notes, we're just going to go through and do a bunch of practice questions that apply some of these. And you might have to flip back up to the top to see kind of the rationale why. But I would, as you do the homework questions, keep that first page of your homework out so that you can kind of refer back to those. That'll help make things go a little more smoothly perhaps. All right, 4 to the negative third. So first step is, you could look at it that way if that helps you, but the key is because we have that negative, we're going to have to put it down below. And technically that 1 doesn't come up to the top because that's not to a negative power. That instead is just the 4 goes and joins it down below, leaving us having to put a 1 up on the top. So 4 to the third there in the denominator, and that's going to be 1 over 4 times 4 times 4, which if you punch that in or do it in your head, you'll get a 64. So 1 over 64. All right, then 7 to the 0. 7 to the 0 is going to be 1. All right, here we have negative 5 to the negative 3. I'm going to say let's do that in a couple of steps. So when we have that, first that negative 3 is going to take that negative 5 and put it down below. So I have a negative 5 to the third. When we put it down below, you'll notice it changes the sign. The negative 3 in the exponent becomes a positive 3. And I would just punch a negative 5 to the third in the calculator if I were you, and that'll give you a 1 over negative 125. But you could look at that as though it's saying right there, a negative 5 times a negative 5 times a negative 5. And when we have that final step, it's not proper to have a negative in the denominator. So we should view this either as negative 1 over 125, or you could put the negative in front, say negative 1 over 125. I like it this way the most, but either one of those will be accepted answers. Don't give me that and expect full credit. All right, this next one. Next one, the key is when you get bigger things like this is you always have to ask yourself, well, what does the exponent apply to? And the common mistake is people will say, all right, this is going to be 6, but that's applying the negative 3 to both the 3 and the 2. If you think back to our good old order of operations, please excuse my dear Aunt Sally, that because we're not solving for a variable, we have to go that way, which means our exponent, figuring this out, has to come in this step, which is before the multiplying and dividing. So when we do this, we have the 3 times that 2 to the negative third. Well, that's 1 over 2 to the third. You could write it like this. I wouldn't if I were you, so I'm going to erase that. But I like looking at it like it's all part of one big fraction. So I have, like, going to turn this into a fraction. That negative 3 is going to take and put that baby down below. So I get 3 over 2 to the third. All right. From there then, instead of just punching it all in my calculator, I'm going to get a 3 over 2 to the third is 2 times 2 times 2, which is 8. So final answer would be 3/8. You can, I suppose, punch this thing right here at the beginning in your calculator. Do 3 times 2 to the negative 3. It'll give you 0.375, but then make sure you change it back to a fraction. Pretty please. Next one. This one you can't put in your calculator. So we look at this, all right, it's kind of like the numerator of a fraction. The negative 3, does it apply to the x, the y, or both? Well, if we had parentheses, then it would apply to both. But there aren't parentheses written in there, so it just applies to the thing immediately before it. That's going to be the biggest thing probably that messes people up in this section. So when you have a variable combination or a number times a number in an exponent, like we did in the one up above it there, the exponent only applies to the one thing immediately in front of it. So then that means this y is going to get put down below. But just like our 3 stayed up in the top up above, the same thing happens here with the x. So x stays, y drops down below, giving us a y to the third, and that's it. We can't simplify because there's no same variables here that can be reduced. That's just the end. Can't punch y to the third in and get it simplified. All right, for this next one, 1 over 5 to the negative 2. It might look bad. It's not worse than the ones we've been doing. When we have that, let's see. So the negative 2 applies to the 5. And again, a lot of people like to look at this and think, ooh, negative 2, so it's going to flip everything. That's actually wrong. It ends up the same way. But what happens is this 5 to the negative 2, that gets pulled up to the top to join the 1. Because the 1 isn't to a negative power, it doesn't move anywhere. So you could view it if you wanted to as well. We have a 1 times 5 squared. So changing where the 5 to the negative 2 is in the fraction changes the negative 2 to a positive 2. And then 1 times 5 squared, well, that's 1 times 25, or just 25. So that's our answer there. Looks like I didn't put a box around this one. Same thing in the next one, down below. We'll jump down to here. X over y to the negative 3. Well, the negative exponent just applies to the y, so we're going to have to change where that is in the fraction. That x, you could view it as though it's to a positive 1, so it's just going to hang out there in the top. So we have an x times y to the third. By the way, when we have multiple variables like this, until we get to where we're adding things as well with exponents, when we're multiplying, we always write them alphabetically. So you'll notice that in this one down below too, w comes before x, comes before y, v comes before z. So we have to write them alphabetically in the numerator and in the denominator. So x here has to come before y to the third. So you could write x times y to the third like I did. I like that. You don't have to have the little dot in the middle. You could just do x, y to the third. That would be totally legit as well. Okay, very last thing. Sometimes people see this last one, they get like all panicky. You really don't need to. You really just take it in little steps, where the one up above, we only had kind of the one step, move this up above. Here we just go and we look at each one and see what we do to it. So w to the squared. Does it stay or does it go somewhere? Well, it stays. So we're going to have a w to the second up in the numerator. All right, then we look at our x to the 0. Well, x to the 0 is going to be 1 if, technically up above I should have written, all variables do not equal 0. So I'm going to go on the assumption that x doesn't equal 0 and say this just equals 1. So I have a w squared times 1, but we don't have to write that in because times 1 doesn't do anything. So this really just kind of drops out in a multiplication problem. All right, then we have this y to the negative 2. Well, we take that, because of the negative, it goes down below. So then I'll do my little fraction line and write a y squared down here. All right, so we did our whole top row. Now we can jump down here to the bottom, v to the negative 3. Well, it's negative, so we're going to have to take that and move that up to the numerator. That'll give us a v to the third. We have to figure out which side of the w should it go on. T-U-V-W, so it has to go in front of it, because like we just said a minute ago, it has to be alphabetical. So v to the third. That one's done. Then very last, we have the z to the fourth down here in the numerator. So it's positive, so it stays. So we have a z to the fourth. So that looks kind of ugly, so I'm going to rewrite it and just say v to the third times w squared all over y squared z to the fourth. And that's it.